All right, here's my attempt to try and explain a four-dimensional object. And right, we're very limited because we've never experienced a four-dimensional object, so we can't really visualize it all too well, especially trying to visualize a four-dimensional object on just a two-dimensional screen. So we're kind of limited, but we can imagine what it might be like. So we start with a point. Well, there is this little point. He's just zero dimensions. He can't move in any direction. He's just kind of stuck there. So then this point decides, he says, okay, I'm going to start to move in one direction. So he moves to the left or right. And that's essentially where we get the number line, just extending forever in that direction, in the positive direction, extending forever in the negative direction. And that's where we get a one-dimensional object. So notice that a one-dimensional object, like your ordinary segment kind of thing, it consists of two vertices at the end. Two zero-dimensional objects connected make our one-dimensional object. Now here's what's a little goofy. Depending on how we look at this thing, where we're positioned, if we look at a segment in just the right way, it'll look like a point to us if we're looking at like just one end. So we might have no idea depending on where we were. So we do have to keep the perspective of how we're looking at it in mind. So we got our one-dimensional object, and he decides, okay, I've moved to the left or right. Let's move a different direction. Let's say I'm going to move up or down. And they decide to move that way. And that's where we get our x and y axis, so that our y-axis generally we think of as up and down, and our x-axis generally we think as going across. We put those together and we get a two-dimensional object. Now, just going back, this two-dimensional object consists of four zero-dimensional objects, four vertices, connected by four one-dimensional objects, the four segments, to create this one two-dimensional object, what we know of as a square. Now again, the whole perspective thing, depending on how we look at this square, if we looked at it from just like the edge, we might not be able to see it. It might just look like a one-dimensional thing to us, depending on where we were. So we do have to keep that in mind that, okay, a two-dimensional object could look like a one-dimensional object, depending on where we stand. Okay, moving on to three dimensions, we got to move in a different direction. And this is where I'm going to switch to like a perspective kind of view. So it's kind of like a tabletop. So there's our little tabletop, and we're going to say, okay, let's go up and down now. So moving this way or this way, oh, we get a three-dimensional object. Great. That we're okay with. We can imagine a three-dimensional object on a two-dimensional screen because we've experienced a three-dimensional object just like this. We've held a die in our hands and we're all good. But to recap here, we have a three-dimensional object that consists of how many vertices? 1, 2, 3, 4, 5, 6, 7, 8 zero-dimensional objects. How many one-dimensional objects? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 segments or edges. So 12 one-dimensional objects. How many two-dimensional objects? How many squares? Well, there'd be 6. 1, 2, 3, 4, 5, 6, just like a cube, to create a three-dimensional object. And again, the whole perspective thing, depending on how we look at it, what might a three-dimensional object look like? Well, if we looked at it straight on, it might just look like a two-dimensional object, and that's all we would really see. It's like, okay, all right, we're ready for the fourth dimension. So we have to move in another direction. And this is where it gets difficult because we don't know how to move in another direction. We've already exhausted all the directions. But we're just going to try and imagine moving in a different direction. Some people imagine like going exploding or imploding on itself as like another direction, so that some people will put it inside or outside. I'm just going to try and go in another direction just so we can kind of visualize, and we go there's a hypercube or a tesseract. So taking that three-dimensional object, the cube that we had, and moving it in another direction is going to get us the four-dimensional object. All right, kind of crazy now. This is where we got to keep things in perspective, so to speak. So first, how many vertices? Well, we had 8 on this cube, 8 on this cube for a total of 16 zero-dimensional objects. How many edges? How many of these segments do we have? Well, we had 12 on this one, if you'll remember, 12 on this one, and then we have to connect each of the vertices from this cube to the corresponding vertex of the other cube. So you have to count 8 more of those. So it'd be 12 plus 12 plus 8. So what is that? 32. 32 one-dimensional objects. How many two-dimensional objects? Well, this gets really goofy because all these faces that we see in there, that like this would make up a face, we'd have to count all those. And we start to get this overlap, and it starts to get really hard to try and count them all. But the weird thing that we got to experience with the four-dimensional object is that it consists of three-dimensional objects. So each of these, like that little prism type of thing, that is one face of the hypercube, so to speak. That would just look like one thing, depending on how we looked at it. That would be a thing. Each of these three-dimensional objects is considered like a face of the hypercube. That's wacky. And again, we can't even experience that because we don't know what it looks like, but at least we can imagine what it might be. So if we were a four-dimensional object, a four-dimensional being, this would just look normal to us. And depending on what our perspective was, it might look like a three-dimensional object for all we know. So there's the best explanation that I can, at least a short explanation. You can Google all kinds of things and start to see different examples and like rotations of hypercubes and that kind of thing. And just here's another way to another hypercube thing that's kind of rotating, a rotating hypercube that's kind of in on itself. So you can kind of see that one cube that he's in the middle there, he kind of rotates out. And then so this idea is like the three-dimensional cube imploded on itself. So it made this inner cube, but then when we rotate it, that inner cube becomes one of these outer things that comes around. So each of those is like a prism. That'll start to warp your mind and keep you up at night. Anyway, hope that explains a little something. Thanks so much.